Welcome back, Geometry. This is lesson 5.3b, the video for something called the incenter, which is formed when we draw all of the angle bisectors into the triangle. So let me show you a little bit about what that could look like right away here. With just like the beginning of the last video, if I'm looking at a triangle, and what we did before was we drew the perpendicular bisectors, which gave us something called the circumcenter, which can move around a little bit. It can be inside the triangle, it can be on the triangle, or it can be outside the triangle. All right, instead of perpendicular bisectors today, we're looking at angle bisectors. So these are the lines that are going right in through the middle of each angle, cutting them in half. So all of these angles are getting cut into two equal pieces by just the definition of bisector. That makes something called the incenter. Oops, sorry about that. Incenter. Okay, and what that incenter does is it's the point that's equidistant from the sides. So what we have right here is we have a point where we could use this incenter as a radius. Since all of these will be the same distance, we could draw something called the incenter, that fits inside the triangle instead of outside like yesterday. So if I click on show incenter, you'll just see that my art wasn't perfect. All right, but this incenter is the circle that's inscribed in the circle, and it's made by angle bisectors. If I would try to start moving around this triangle and see what happens to the incenter, see what happens to that circle that goes inside, it will never be outside the triangle. So I know with the circle or the circumcenter, that radius could be inside or outside, but the incenter will always be inside that triangle. So one thing just to bring up again, equidistant means that that two objects are the same distance from something else, from a third object. Okay, equidistant means same distance. So theorem 5.7 is the concurrency of angle bisectors theorem. Here's what it's saying: the bisectors of the angles of a triangle, so angle bisectors, are concurrent at a point that is equidistant from the sides of the triangle. So the angle bisectors are drawn in red. They're cutting each angle in half. They meet at a point P that's called the incenter, and that incenter is the same perpendicular distance. The incenter is equidistant from all three sides, which means I could draw a circle that fits perfectly inside the triangle, which we would call inscribed. Okay? So the incenter of a triangle is the point of concurrency of the angle bisectors. Angle bisectors are where the incenter would meet. What happens is px would equal py, which equals pz. That's these distances here. So those are like the radii of the circle that makes a perfect fit inside the triangle. Okay? The incenter is always inside. It's never outside or on the triangle, no matter what type of triangle it is. In yesterday's video, it could have been inside or outside or on. The incenter is always inside. Incenter is always inside. Okay? A circle is inscribed in a polygon. If the sides of the polygon are tangent to the circle, that means that the sides will only touch the circle in one point. A polygon is inscribed in a circle if the vertices of the polygon are on the circle, and that's what's happening with our circumcenter a little bit from yesterday. Okay. You might get a question asking you to name the point of concurrency of the angle bisectors. This is saying name the incenter. That's what we're looking to find right here. The point of concurrency of angle bisectors, that's where the incenter comes from. So one thing that I would have you do on the problem like this is find an angle bisector. So you want to look in the corners and look for those little arcs that mean congruent. I would trace that line then. Okay? That line that's blue is an angle bisector. We're looking at where the incenter is. If I look at these arcs right here, I can trace that one, and I see where I have an intersection. The intersection, if I trace it back, is P. So P is the incenter of the triangle. Okay? They're going to throw in some other segments that are not angle bisectors to try to throw you off, so just be careful. So that's why I said start in the corners where the angles are marked to be congruent. And then if they have the same amount of arcs on both sides, you can safely say that is a, sorry about the bell, that is a angle bisector, an angle bisector. So this last line M through M here, there's nothing marked for the angles, so this one I'm not going to trace because it's not an angle bisector. I already have what I need. The answer happens to be P again for the angle the incenter with the point of concurrency of the angle bisectors. So if I ask you just to label it, which one it is, there might be a messy picture, there might be a lot of letters that could be options. Just try to trace those angle bisectors and see if you can't figure it out. All right, identifying and using the incenter of a triangle. Okay, here's a picture. We're not going to do so much of finding angle bisectors on a graph like we did with perpendicular bisectors and circumcenters yesterday. It's going to be more algebra type problems to solve, and most of the time it's going to be set some things equal to each other. So with that in mind, what we're going to do is we're going to look at where these angle bisectors meet each other, which is right here, which is G. If that's the incenter, what I know, so I know G is the incenter. All right, it's where the angle bisectors meet. That means, for me, GE equals GD equals GF. So GE equals GD equals GF. Those are all the same because I could make a circle all the way around those 3 points that would be inscribed in the triangle. Okay? What I know, let me erase some of that though, because I want to be able to draw on this picture now. What I know is equal is right here, GF, GE, GD. I know that GE is 2x minus 7. Okay? I know that GF is x plus 4. What I know is those two things have to be equal to each other if that's really the incenter, which I know it is. So that means I can set GE equal to GF since they're equal to each other, and I can say 2x minus 7 equals x plus 4, and that solves pretty quickly. Add 7 to both sides, subtract x from both sides. X is equal to 11. They don't want us to plug anything in. Oh, yes, they do. Sorry about that. They want us to plug in and find the length of GD, except for they didn't give us anything that would be something where I could plug 11 into. So what I can do is I can plug 11 into any of these. If I do 11 plus 4 right here, I get 15. So they should all be 15. Maybe I'll check one more. This would be 22 minus 7, which is also 15. So these should all be 15. So I could say my answer is GD equals 15, even though I don't have anything for GD as far as an expression that I can just plug x into. Okay, let's try another one. All right, what I want you to do is pause the video, and I want you to try to set it up and solve it. I'll help you answer the other part about the reasoning question after you give it a shot to find what QO is. All right, so that's what I want you to do. Pause the video and solve this one. When you hit resume, the answer will be there. So like we talked about, here's our answer for QO. You should have got 61. That comes from setting the x's equal to each other and solving for x. You could plug x is 5 into either equation, the 2x plus 51 or the 5x plus 36. Either way, you'll get 61 out. Now, this one says, is it possible for QP to equal 50? Here's QP, and they're asking, can that be a 50, that side? If I look at this triangle, I just found that this side equals 61. Okay, I know that that third side equals 61. But 50, if my right angle is here, I have a right triangle, this should be my hypotenuse. So I can't have my leg be 61 and the hypotenuse be 50 because the hypotenuse has to be the longest side. So it's impossible for QP to be 50 units long. The hypotenuse must be the longest side. Okay, that's all that one is asking for right there. Okay? So a lot of times we're setting things equal to each other. Okay? Alright, one more time. They already put everything on the picture for us, but since these are angle bisectors, they're meeting at the incenter, which means the two pieces here, x plus 5 and 3x plus 7, have to be equal to each other because they have to be equidistant from the incenter to that side of the triangle. So x plus 5 must equal 3x plus 7. They're just asking us for the value of x. We're going to subtract both sides by x and subtract both sides by 7. We get negative 2 equal to 2x. When we divide both sides by 2, we get negative 1 equal to 1x, and that would be our answer. You might be wondering if a negative answer is okay. In this instance, it's just fine. If I plug negative 1 plus 5 in there, I get a total of 4, which is positive, which is okay. I can have negative x's or negative variable values. I just can't have negative side lengths. So if I plug negative 1 into this one, that'd be negative 3 plus 7, which should be the same as the other one, and it is positive 4. Okay? If I look at this question then, it says, where should the fire station be placed so that it is equidistant from the grocery store, the hospital, and the police station? So this is actually going to be reviewed from yesterday. Equidistant from these three things, these are all endpoints. Police station, hospital, grocery store. This is asking us to find the circumcenter. So if it's on a graph, it's probably going to be a circumcenter question. If it just has algebra in it, it's probably going to be an incenter question. What they're asking us to do is put the fire station in the smartest spot so that it can get to anything, the police station, hospital, grocery store, in about the same time frame. So remember what we're doing is we're drawing perpendicular bisectors, at least 2 of them. So what we need to do is look for the easy sides to draw in. So for right now, the easy sides would be between hospital and grocery store, since that is horizontal, and between hospital and police station, since that's vertical. All right, so we go halfway in between the hospital and the grocery store, which has a distance of 6. So I can put a dot 3 away from each point, each endpoint, the grocery store and the hospital. I know that that's a midpoint now. If I go perpendicular through the midpoint, I'm going to have a perpendicular bisector. Okay? The other one is also a distance of 6. So if I put a dot 3 away from each endpoint, that's going to be congruent right there. I have a midpoint. Perpendicular through that midpoint is the perpendicular bisector. So we just found the circumcenter. This is where we should put our fire station. All right? Because that would be the easiest way to get from the fire station to any of the 3 points. I know my circle's kind of inaccurate, but the fire station would have the same distance from each vertex. Okay, so the answer then, we just want to put the point that we would have. It looks like our axis is right here, our 0, 0, so it would be over 1 and up 1. So we would want to put it at 1, 1 on the graph. Okay, so that's just a quick review of circumcenter. All right. Last thing I'll have you do here for these notes is answer these questions about finding the point of concurrency of the angle bisectors. Pause the video quick and see how you can do on these. Your answer will just be 1 letter, and that's all. When you're done, click resume and you'll see those answers. You can go ahead and give yourself a quick check there. Across the top, our answers would be P, I, and W. Across the bottom, our answers would be F, N, and P. So those, again, we're tracing the angle bisectors and seeing where they run into each other. That's it for angle bisectors. They intersect at the incenter, and usually we're setting 2 things equal. Thanks for watching.